Today we meet for a second day of the conference. My name is Kinga Gruszecka and I represent the Polish Space Agency. I'm joined by
Jakub Semachowski
and
Katarzyna Malinowska.
Before we will go into other presentation and discussion, I would like to welcome Mr. President of Polish Space Agency, Professor Grzegorz Wrochna.
Thank you very much. I hope you can hear me.
Yes.
Very good. So this year in Poland is dedicated to famous science fiction writer Stanisław Lem. Therefore, my almost every speech I begin with some thoughts about his literature. And the thought I'd like to share with you is very general. Why the science fiction literature is so popular? Why it is so attractive? And my answer is because it's all about risk. Traveling through space is risky. Dealing with harsh environment on different planets is risky. Dealing with powerful equipment of rockets and spacecraft is risky. Meeting aliens is risky. So it's all about risks. Remove the risks from science fiction stories and you make them boring. Nobody will read them anymore. So it's all about risk and therefore we like it. But we like it because we don't need to bear its consequences. Whatever happens is just enough to close the book and you are still sitting safely in your armchair. It's not like that in everyday life. But in fact, everyday life was also pretty safe and we somehow forgotten how to deal with risks. Perhaps our Stone Age predecessors were much better in assessing the risks and mitigating their consequences. And then suddenly the COVID-19 came and we have realized that we have to deal with risk every day. We have to make the decisions. We have to estimate whether can I meet my friend or not? Can I go to the shop or not? Should I wear a mask or not? And when you look at the dispersion of people behavior, you see that we are not good at all to assessing the risk. Therefore, if we work in the areas when we have to assess the risk in a professional way, like in space technologies, then we have to have special tools, we have to have procedures, we have to have regulation and so on and so forth. And we will be talking about this today. Let me just share with you one example from my professional lives. For some time, I was working with nuclear reactors. And then to take care about risks, one used the principle which is called defense in depth. What does it mean? That you design a system that it should work, I mean, with 100%, you're sure 100% that it will work, okay? And then you assume that for whatever reason, it doesn't work. And you design a backup system or some mitigation system. Again, you design it that you are sure that it will work 100%, okay? And then again, you assume that even this backup system will fail, even you are not able to give the reason for that. And then you design a next barrier. So this is so-called defense in depth. I mean, today, we will be learning about different ways of assessing the risk, mitigating the risk. And this is indeed very crucial in the professional life in the space sector, not just in science fiction novels. Thank you.
Kasia, we had a week of break from first day of the conference and till today. Any feedback, any thoughts after this week?
Yes, of course. Today we have an engineering session, but last week we talked about managers' risks and legal risks in space. And of course, I'm quite familiar with the legal risks. And we had a very nice roundtable of experts, of international experts. And we were talking about how risky it is not to have space law in a country which is very anxious to go into space. So we have very nice takeaways. We were going to publish a kind of guidelines for space legislators. So be with us and today and wait for our report.
Thank you. So today it's going to be more about engineering, about projects, technical projects. Before we go there, I would like to ask Kuba, who is a community manager and manager of Cosmic Hub, where we are now. And I remember when we were invited by Kozminski University to join the conference this year as well, as POLSA, we discussed if networking might help in mitigation risk. After these few months working on mostly a platform to network and to solve problems together, what are your thoughts?
Thank you very much, Kinga, for this introduction. So, as you know, I think that's really what matters for us when we try to mitigate risk, is to talk about our failures. And actually, this is what we can learn a lot from our colleagues in the United States, for example, to share what has gone wrong, but also celebrate our victories. So by sharing the knowledge that we can do also in Cosmic Hub, we can really try to make solutions for it that haven't appeared yet. So I guess that's one of the main reasons for the Cosmic Hub to exist, really to facilitate the networking, to make the risks not really present in the projects, when you can mitigate them very effectively at the very stage of the project. So I guess that's also what we're gonna hear about today, and also how to mitigate technical risks, but also risks related to the lack of proper communication. And also we'll talk about how to turn risks into opportunities, because also that's what's very important. When you have a risk, you can also have a solution that can answer a lot of our future needs that we are not really certain about at the current moment.
That's tricky. I don't fully believe we can turn risk into opportunity, but well, who is our first speaker today?
Yes, so our first speaker is Andrew Wolahan, a spacecraft system engineer from European Space Agency, involved for a number of years in in-orbit servicing and clean space projects, initiatives, and technology development programs. And Andrew will tell us about the risks involved with this kind of projects. Thank you very much, Andrew, for agreeing to be here with us, and I now give the floor to you.
Thanks for the invite to this session. And I'm going to try and share my screen, if that's possible. There we go. I think, can you see the PowerPoint? Can you see my screen?
Yes, we can see now your full screen, yeah.
Yeah, perfect. Okay.
Not the presentation mode, but right now, yeah, we can see the PowerPoints.
So let me switch into presentation mode and then swap like this. Good. Okay.
Yeah, great.
So sorry for that. So when I was asked to give a let's say a presentation on the risks associated with in-orbit servicing or debris removal, I also thought that when we talk about risks, it's things that potentially will occur in the future. So we try for risk mitigation. We try to quantify what's the probability of these risks in space missions. What's the impact in terms of cost or mission duration? Will it extend the mission if this risk actually comes to fruition? But risks are very closely linked with challenges. And let's say in the way we use these two terms, risks are things that may happen in the future. Challenges are things that have occurred that we now need to deal with, that have become real problems. So effectively, you have a risk register that we manage within our projects. Once they occur, they become challenges that we then need to try work with. So that's why I try to cover both of these, because depending on the technology development or the mission that you're supporting, some elements are risks, and those elements in other projects are challenges because there are things that have actually occurred in that program. So today I'm just going to give you a short presentation into clean space in orbit servicing as a whole. I'll try to go through some of the specific technical challenges and risks that we've seen in the various projects and things that we've been in. And I'd also like to share with you, some upcoming future activities in this area, because Polish companies have been heavily involved, particularly in the area of in-orbit servicing and CleanSat. So just to mention some upcoming activities, I think that could be interesting for industry. So Clean Space is an initiative within ESA, which was established about 9 years ago, and it focuses in these three areas. So one is eco-design. With eco-design, we want to try quantify what the environmental impact is of a space mission on ground. So not just with ozone depletion or debris generation on orbit, but also CO2 generation, water eutrophication, water pollution, etc. So We have for space missions, particularly, we have 15 different criteria where we try for any space mission or launcher, understand what the environmental impact is, what risks these pose, and what sorts of mitigation actions we can take to reduce either the environmental impact. Because, of course, some of these indicators are also human hazards. Like we know by using hydrazine, there's a high risk that humans have issues after handling these types of fluids. Then the other two elements, CleanSat and active debris removal in orbit servicing, both of these originally focused on the issue with debris. So we know for the last several decades that debris is a problem. It's one of these things that is growing exponentially now as we see many more satellites being launched. And as we have collisions and breakups on orbit of active satellites or satellites that have reached their end of life. So the debris population is increasing, and there's two ways to deal with this. One is what we term CleanSat. This is space debris reduction. So with CleanSat, we aim to develop a set of technologies that will ensure that future satellites don't generate debris on orbit. By not generating debris on orbit, then we reduce the risk from debris for future satellites in those environments. So this is things like once a satellite reaches its end of life, it has to remove all of the stored propellant or stored energy on board, such as reaction wheels or the residual energy in batteries, because these are the typical things that we see satellites breaking up because that there's a discharge, a thermal runaway in the battery, or the tank, after being on orbit for 30, 40 years, going in and out of many thermal cycles, ends up exploding because of the residual pressure. So CleanSat aims at looking at technologies to limit for future satellites the risk of debris generation. But we know now that even if we design satellites in the future to do this, or for the satellites that we've launched in the past, that there is still a problem. If we have no future launches, the debris environment is going to continuously increase because of the collisions between the debris already on orbit. So what internationally is recognized now is that we need to start removing debris that's on orbit. And this is why we have this third branch down at the bottom called active debris removal. And this is very closely linked with in-orbit servicing, because to do active debris removal, you need to rendezvous and capture an object. And it's even more complicated than in-orbit servicing, because in many instances, this object is spinning because it's not controlled. It doesn't have three-axis stabilization. So there's a huge amount of risks or challenges that we face trying to design a mission and the technologies to really do an active debris removal mission. So I'll go through the ADR and in-orbit servicing elements of clean space in a bit more detail now. I think first, just to take a step back, why do we do in-orbit servicing? So the first one is that we want to solve issues with existing space assets. So to repair something or to do debris removal. Or the second option is that we could increase the utility of existing space assets, such as refueling the satellite or performing life extension. And life extension, for anybody involved in this area, you may be familiar with the Mission Extension Vehicle 1 and 2 launched by Northrop Grumman in the last 2 years, where they've actually started providing this as a service on orbit. So Northrop Grumman has launched 2 vehicles now, which have both rendezvoused and docked with different satellites from Intelsat, and they're providing as a service AOCS takeover, because effectively Intelsat realized that their satellite didn't possibly have enough propellant to continue operating, but the actual payload and equipment on board were working quite well. So instead of launching a new satellite with the additional propellant or to provide the service, they instead procured the service from Northrop Grumman for a separate satellite to do the AOCS takeover. And then moving, let's say, a little bit more into the future, you could think about new sophisticated systems on orbit by being able to manufacture or assemble complex things. Like we know for telecom satellites, particularly in GEO, we want as big as possible a solid parabolic reflector, because this is directly linked to your throughput and performance. But a solid reflector is constrained by the size of the launch fairing. So if we can manufacture these things on orbit, we have new sophisticated systems and more effective services that can be provided on ground. And the fourth one is to provide potentially even more in the future low-cost solutions for system development, like recycling. So being able to rendezvous and capture a satellite, take it apart, maybe take the solar arrays and put them on another satellite that is still operating to try and enhance that. So to start recycling satellites, and this is, let's say, the fourth one. So in the challenges of risks, I think there's 4 high-level risks. I'm not going to go highlight specifically the technical risks associated with debris removal, just more at an abstract level, but I'm going to highlight 4 today and then give you examples within ESA how we're trying to tackle these specific challenges or risks. So personally, I've been working on in-orbit servicing and debris removal now for 8 years, and this is one of the biggest challenges that we've had within CleanSpace, is trying to get commitment for a mission to be implemented. We worked together with a number of companies in Poland, such as SENER and PIAP, to try and develop the ED-Orbit mission, which we didn't get funding for. So we've been going through this process, trying to get funding, which we've recently done. And so just to give you a bit of the ESA vision for in-orbit servicing, so this is how we're trying to mitigate or to support this challenge of getting commitment for funding. So one is that at the last ministerial, we presented the AIRBUS mission, active debris removal for in-orbit servicing. There's some Polish companies involved in this particular mission, and they play really a key role in supporting particularly the capture mechanism that we're developing. So AIRBUS I'll present a little bit on the next slide, but effectively we want to launch this satellite by 2025, and it covers these capabilities. So debris removal, transportation, and inspection. So you could think that in the future, the company who does this mission could do debris removal, but they could also do inspection missions. When we talk about risks, for instance, insurers are often very interested when an operator makes a claim. For instance, my satellite has stopped operating. I want the insurance to be paid so I can procure a new satellite. The insurance company, the first question is going to be, well, what happened? Because we need to make sure that whatever happened, you mitigate that potential failure on your next mission. In some cases, the operators, they don't know. Maybe the satellite stopped communicating, or maybe they don't get the correct information. And so to be able to do an actual inspection of a satellite could support, for instance, operators or insurers in carrying out their service. So AIRBUS is really for debris removal. Moving forward then, what I mentioned on the last slide, of course, so towards 2030, ESA really wants to start working on these areas. So being able to refuel satellites on orbit or perform AOCS takeover, to do refurbishment. And by refurbishment, we mean going to the satellite and replacing some equipment that has failed, like a star tracker, a solar array, or an antenna, a battery, or something else that has failed on the satellite. So replacing equipment to make the satellite be able to return to service. And then the third element is to look at the assembling and manufacturing. So within ESA, we already have some experiments for manufacturing and 3D printing that are going to the ISS. So we're demonstrating a number of the key technologies in these areas. And we've invested a significant amount together with the member states on all of these elements. So really, having worked a lot on the technologies, what we did now in preparation for the next ministerial, back in March, we released a request for information on in-orbit servicing. And we aim for industry to provide us concepts, ideas. So this is currently an open call by March, covering these areas. I have a slide on this later on. And then moving towards 2030, also towards recycling, so designing satellites to be recycled at end of life. So just the AIRBUS mission, for those that aren't familiar. So this is really to solve the risk for future satellites by removing a debris object that's on orbit. And considering this hasn't been done before, nobody's ever removed an actual debris from orbit. This is really a challenging mission, first of its kind, with a lot of technical risks. So just to give you an idea of the mission scope, so the aim, it's led by ClearSpace, which is a Swiss company. They aim to launch with Vega into around 500-kilometer circular orbit. They do some commissioning to the target orbit. The target is this Vespa upper part. So it's an upper part of Vega that's been on orbit for about 15 years or so. Once they get to the orbit, they need to do an inspection to understand what's the spin rate, the attitude. One of the big technical risks with this is that it's a symmetrical object and it's dark, which means that we cannot observe it very accurately from ground. So it proves as a real challenge for us to understand what is the actual spin rate and spin axis of this target. And of course, it's been on orbit for 15 years. It's made of carbon fiber and has other materials here. And these materials have degraded over time. They've had suffered from atomic oxidization. They've had micrometeoroids impacting the surface. It's had discoloration as well from UV radiation. So all of the VESPA characteristics from what they were at launch to now have evolved, and it's very difficult to understand what is the exact values that we need. So there's a lot of technical risk, and as a result, we add a lot of margin onto this as well when we're designing it. So typically we see objects spinning at 1 or 2 degrees per second, but the ADRIOS mission at the moment is being designed for in excess of 10 degrees per second. And that's why they've come up with this tentacle system that you see here. So they have these 4 capture tentacles that they're designing to effectively capture before contact. So one of the big risks on orbit when you're doing an orbit servicing is that the minute you touch an object on orbit, because there's no friction in space, effectively the attitude propagates in a very strange manner. So we want to make sure that the object is encapsulated within these 4 tentacles before we change any momentum of the object. So that's one of the big technical challenges. So with all the for in-orbit servicing, for all the capture systems, one of the requirements that we always encourage industry to adopt is this capture before contact concept to mitigate the technical risk. And after they've captured it, of course, it's spinning. So once we've captured the object now, we're both spinning together. So we need to do a detumbling. And afterwards, we do deorbiting, so to remove the object from orbit. And again, this is to be done by the end of 2025. And there's some Polish companies working in support of the capture tentacles at the moment. So they're really providing some key capabilities in verifying this concept of the tentacles. Then the next step, so this is the thinking beyond ADRIOS, is the ESA request for information for in-orbit servicing. So the idea here is that we really want to involve European industry together with a client and a servicer. So we want industry to come going, okay, we're company X, we want to build a servicer, and company Y, who operates this spacecraft, has said they're very interested in our procuring our service. So this is the concept. We've left it open. It's for industry to decide whether it's AOCS, takeover, refueling, assembly, manufacturing, or refurbishment. This is really up to industry to decide, together with the operator or with the client, what's the most interesting. In terms of timeline for this, so we issued the RFI back in March. I've left a link here for you. So it's just if you go to ideas.esa.int, you find all the information. On May 17th, there's the deadline. After this, as ESA, we'll have a dialogue phase with each of the companies who've submitted a proposal. And we'll basically use this dialogue phase to try and understand what are the needs of the clients and European industry who want to build these services. And once we've got a good understanding of this, we're going to write an in-orbit servicing proposal request, which we'll release, let's say, in the 3rd quarter of this year, in around August, September. This will be open for a few months. And then in February 2022, we're going to make a down selection. And there's some maturation contracts around 250 kilo euro that we're going to place. And the idea is that we'll select up to 3 of the proposals received from the in-orbit servicing proposal request to build towards a ministerial proposal like we did with ADRIOS, where we have a mission at the ministerial for in-orbit servicing. So this is the concept at the moment. So that's in terms of missions, right? The first challenge, trying to get a commitment for a mission. The next one really is trying to understand what is the feasibility of the system, the in-orbit servicing system concept, whether it's debris removal or refueling, and to identify the key technologies that we need to mitigate the risk of, and to try to develop these technologies. Each of them, of course, come with their own challenges. So for this, I'd just like to go into a case study on debris removal. So I've just got 2 slides on this. So we spent, also with the involvement, as mentioned, of SENAIR in Poland, a couple of years working on this mission called ED-Orbit. And ED-Orbit was a mission that we were studying to remove NVSAT from orbit. NVSAT was a large satellite launched back in the early 2000s, which is about 10 ton. And it's a very big object. It's about 10 meters long by 4 meters by 4 meters. So it's quite a big object, big in mass and big in geometry as well. So this really posed a huge amount of challenges, let's say, or risks in the design, because we need to make sure it's, when we do the re-entry, it has to be controlled re-entry. So there's no risk to population or to property on ground. So we needed to control the trajectory during the actual re-entry burn, which is a very big challenge when it's such a big object that you're trying to re-enter. And The next challenge, of course, is that ENVISAT, as I mentioned, was launched in early 2000, which meant that it was built and designed in 1980s and 1990s, let's say pre-computers. So all of the information that we have on the detailed design of ENVISAT is in an archive in our ESA site in Esrin, in Italy. And there is a huge amount of paperwork, of course, developed for this mission, because it was a very big mission. So there was a lot of different suppliers from all over Europe. So there's lots of documentation. But it's very difficult to find detailed information because it's in an archive in Esrin. So when we needed as ESA to try get information on, well, what did the launch adapter ring look like? And what was the composition of the structural boom? Because we're trying to identify the capture interface. So you need a rigid body near or nearly aligned with the center mass that we wanted to capture. So we tried to get information on all of these, and each time this takes quite some time to get. In the end, we settled on the launch adapter ring because we could get quite some information from Arianespace on this, because it's a launch adapter ring that they've used for many missions. So we baselined this. We started doing some technology developments. And then eventually we came across a few pictures of ENVISAT provided by one of our colleagues from the integration hall, where we actually saw these little tapes, optical reflectors here you see along the launch adapter ring surface. This isn't in any of the documents that we saw, and it posed a huge technical risk, because in the end it meant that where before we knew what we thought we knew what the surface finishing was of the launch adapter ring, now we have this tape, which poses two risks. One, we start getting let's say some reflections in our optical trackers, in our cameras that we're using to track the object in. So you get a lot of stray light from the sunlight reflecting off this. And the second one for the capture system is that we don't know how this will have degraded over time. So it's very difficult to predict what the coefficient of friction is going to be when we try capture this. So this is, let's say, from a technical perspective, a very, it seems like a detail, but it poses a lot of technical risks to our developments. Another one I think that's interesting to mention is the spin rate. So for instance, ENVISAT was operational until the end of 2012. We lost contact on this blue line, so around March 2012. And we were tracking from ground just every now and then, sporadically every few weeks. ENVISAT luckily had a retro reflector on board, and we were using laser rangefinders from ground to try to predict what the spin rate was. So you can see the spin rate evolution here over time. And what's interesting to note is that after we lost contact, the spin rate quickly spun up. Then it stopped spinning and it started decreasing, and you see now it's kind of stabilized around 0.3 RPM, or just below 2 degrees per second. But it did go to a peak just beyond 3 degrees per second. So one of the big challenges for us, or big risks, is that we don't know why it spun up, because we have no information from ENVISAT. So we did a lot of estimates on if the reaction wheels had offloaded, could it have imposed part of this much energy? No, it couldn't. If a debris hit it, could it have resulted in the spin rate? No, because the energy required to spin the satellite up would have resulted in a collision, and we would have had a debris. We didn't notice any debris. So the conclusion that we came to, but we don't know for sure, is that one of the thrusters must have opened and released some residual propellant or gas. And that's possibly why the ENVISAT spun up, because we know we had some remaining propellant on board when we lost contact with it. So that's just some very specific ones, of course, for ADR, but there's many other challenges to do with maturing the sensors or the capture equipment. Communications. So with this type of mission, for in-orbit servicing in particular, we want to be able to monitor the approach and capture. So in order to do this, we need to be over a ground station. But of course, you can't get continuous ground station coverage. So you'll end up with just a limited collection, maybe of 5 or 6 ground stations. And from this you can derive, well, what's the window of opportunity, the actual timeline that we have. And in the end, typically you get about 20, 25 minutes of continuous ground station coverage. And in this, you need to fit the final rendezvous, the capture, the confirmation of capture, and then the detumbling. Otherwise, if you don't fit all of that, all of those functions within that timeline, then you end up doing things without ground station visibility. So if something goes wrong, we can't interact from ground, and we don't know something's gone wrong until 20, 30 minutes later, till we get ground contact. So some other two of the major risks with this type of mission, of course, one is that we need to avoid debris generation, but we're talking about contact between two objects on orbit. So there's a lot of requirements, technical requirements, that we end up on the GNC and the capture system in order to mitigate this risk. And the other is the actual casualty on ground. As I mentioned before, for debris removal, we need to make sure when we re-enter in an uninhabited area like the South Pacific or the Atlantic. And when this happens, we need to design our system, the full thruster chain, to be able to control and target a very specific location, like we did for ATV. So that's in terms of system development. In terms of technology developments, over the past few years, we've been working also a lot with Polish industry on capture systems. PIAP at the moment is developing a robotic arm for in-orbit servicing, for instance. But we're also working with other companies to develop a hexapod, grippers for in-orbit servicing, grippers for refueling, for instance. And we're also supporting the development of test facilities. Then in terms of GNC, so these are the two typical major areas for technology maturity for in-orbit servicing. One is for the capture and the other is for everything for what concerns rendezvous. For GNC, we've been developing different types of controllers and sensors as well, such as LiDARs, multispectral cameras, and of course all the image processing algorithms that need to go together with that. So that's it in terms of in-orbit servicing from the system perspective and technology. But the other flip side to the coin is that in order to reduce the risk or increase the robustness of in-orbit servicing, we could design future satellites to support in-orbit servicing. I gave you the quick challenge or risk that we had when we were trying to design the deorbit mission and trying to find where on NVSAT should we capture. This was not a trivial problem. It took quite some time to settle on the launch adapter ring. So one of the other things we're working on now, just to put this on the roadmap effectively, is for future satellites. We want to design them for removal or design them for servicing so that they have different types of technologies on board that can mitigate the risk of rendezvous and capture, and hence mitigate the risk of debris generation, which is ultimately what we want to avoid. So something interesting to note is that for all future Copernicus missions, so these are the ESA Earth observation missions, for the ones that will be launched beyond 2025, there's six of these missions being developed now, and by Thales, Airbus, and OHB, and they all have a requirement to adopt the space debris mitigation requirements as a baseline. But in case they fail to do for instance, the disposal burns, for instance, if the satellite fails before it can manage to do this, they have to implement this concept of design for removal, in order that if they do fail, then it's simpler and possibly cheaper and less risky to design a chaser to capture the target. So in terms of technologies, one is that we know the chaser, so this would be the in-orbit servicing vehicle, will have a camera on board to do image processing on the target to understand the attitude. And in order to increase the accuracy of this, what we're going to host on board are markers to support the navigation, to support the attitude determination. So we've got a mixture of 2D and 3D markers. 3D specifically for the very close phase to support us in pitch and yaw. Because of course, when you're very close to the target, you don't have a lot of references. You just see the back plate of the target. So having a 3D marker gives you more information. Then the other technology they'll embark is a mechanical interface, which we've called MICE, which you can see here. And there's two other types of technologies. So one is that one of the big challenges is the spin rate, because this drives the capture system, it drives the actuators like the thrusters. So we've requested that the Earth observation satellites use the magnet workers to detumble at end of life. And in order to support the accurate tracking, I mentioned, for instance, previously for the ADRIOS mission, it's a big challenge for us to monitor accurately the attitude, so the spin rate and spin axis of the VESP upper part. So by putting on board these retro reflectors, it'll enable us to more accurately understand and propagate what the spin axis and spin rate is of targets in the future. So these are a set of technologies that we're going to embark on the future Copernicus missions. There's also other system level requirements that they have to have on board. For instance, we can't have it that they deploy a solar array that blocks the mechanical interface. So there's many other configuration constraints that they have to abide by. So just something I think to mention for you, which might be interesting. in the next, what we're working on at the moment, so in the next 2 to 3 months, we aim to issue an ITT, an invitation to tender, of about €1 million within the space safety program, where the objective is to develop both interfaces, one for the Earth observation satellite with all of the equipment I just mentioned, and the other one to build a service Earth capture bay, so we call it CAT, with the rendezvous sensors, the clamping mechanism, and the capture system. Really, let's say, in one setup to demonstrate end-to-end the actual performance of all elements. So the capture system performance in terms of errors and torques, and the let's say the performance also of the multispectral or the visual cameras. And this is really for Copernicus, so it's for large satellites. So that's something that will be coming out soon. It will be open competition as well. And another activity I think is interesting to mention is that what we've heard from operators is that they're also interested to embark technologies to support not just removal, but also in-orbit servicing. But there's a bit of reluctance to do this, because if they embark a technology from company A, then company A will be the one that has to provide the service, most likely provide the service to the operator. So the operators are interested in, for instance, if the agency was to support in the development of these technologies for smaller platforms, because smaller platforms, for instance, we can't have such a big mechanical interface. The markers need to be smaller because we don't have as much real estate. They may not have magnetorquers on board, so we may need some other detumbling technology in order to limit, let's say, the risk of in-orbit servicing. So this is another activity that we've proposed. The statement of work is also being written for this now at the moment. It's going to be within ARTES AT. It's an 800 kilo euro activity, and yeah, it's in the work plan at the moment. And the idea for this is really to get it to TRL 4. So it's not clear yet. The operators are interested in embarking these technologies, but this is, let's say, will be a technology driven activity. And the last one, I think, just to check for timing, the last one I just want to mention is that there's a lot of companies working on in-orbit servicing, and we need to make sure that when we do this type of mission, because it involves rendezvous and capture, that we do it, let's say, with a certain level of safety in order to limit the risk. So when we talk about this, there's no, for instance, technical guidelines yet. So if you want to build an in-orbit servicing mission and then go to an insurer and ask for insurance against for providing the service, there's no technical guidelines where you can go, I've adopted these guidelines in building my mission, and I've taken into account all of these. Therefore, I've designed with the best practices in mind. At the moment, this doesn't exist for in-orbit servicing. It exists a lot for rendezvous and capture, for instance, on the ISS, where there's human-rated missions. But when we talk about human-rated missions, because there's humans in the loop, and therefore the consequence of a risk is much more severe, the types of requirements that they have, for instance, are that you need 2 fault tolerance, just to give you an example at equipment level. And this means that your equipment can fail, and you still need to be able to operate, and your equipment can fail again, and then you still need to be safe. Which means if you have a thruster to do the rendezvous, you need redundancy to do the rendezvous, and in case that fails, you need another thruster in order to do a collision avoidance maneuver. So you end up with lots and lots of equipment. It ends up being a complex spacecraft because of the level of redundancy and the type of failure detections that you have on board. That doesn't necessarily work for in-orbit servicing if you want something to be commercially profitable. So this is something that industry has pointed out to ESA a few times in the past few years. So we set up an ESA working group back in 2020, and this involves service providers, operators, insurers, agencies, manufacturers, also equipment level suppliers. And we've been working with them now for over a year to build a technical note with a guideline, let's say guidelines on what types of requirements you could adopt if you're going to do this type of mission. So this is really a technical note. It'll be provided as an input to ECSS, to ISO, to the European Operating Framework, CONFERS, and UN. So all these other international entities working on standardization. We're not writing a standard. We're really writing a technical note of, if you're going to do this type of mission, based on our experience, this is what we believe you need to look at in terms of the risks and what sort of requirements you should adopt to mitigate these risks. So that's it from my side. I just wanted to mention that Clean Space, we have a blog. If you'd like to follow us, we often mention some upcoming activities on this. We will have some industry days later this year. The exact dates aren't defined yet, but it'll be announced on our blog. And if you'd like any further information on any of our activities, or you've got questions in this area, please just feel to reach out and contact us at cleanspace@isa.int. So I think, Jakob, that concludes my presentation. I'll stop sharing now. I think we have time for a few questions.
With more and more companies in Poland being interested in clean space initiatives, I think it's really welcome, interesting for all the parties involved. And I see that we have two questions in our chat box, and the first one is from Krzysztof Natusiewicz about the interagency cooperation on development and agreement with regard to future standard grapple fixtures. Do you know, Andrew, anything about this cooperation regarding the developments?
No, there's been some discussion on this in different forums, but there is no internationally agreed standard at the moment. So with the Copernicus mission, we've gone ahead and we've started to build this mechanical interface, which will be adopted. And we aim to make this interface, the mechanical drawings, etc., available for other entities to adopt. So this could potentially become a standard. I mean, there's two ways to make a standard. One way is to write the requirement, and the other one is to just get adoption of a specific technology. But for the moment, there's no agreed standard yet, and I'm not aware of any working groups to build towards such.
I see. Thank you. And there's a second question from Krzysztof about the magneto-torquers and why they are not allowed at the client satellite site.
Maybe this is in reference to the second activity. It's no, the magnetorquers could be on the client. Let's say when we talk about Copernicus, they do adopt magnetorquers. So there will be magnetorquers on these. It's just that with the other activity where we're looking at smaller satellites, less than 100 kilos or 150 kilos, there are systems where they do not have magnetorquers. It's not that they're not allowed. It's just that sometimes these systems don't have them. And with the Earth observation satellites, this is the technology that we're using in order to detumble them at the end of life. So if the satellites spin up, possibly the magnetorquers could be short-circuited. And this would mean in low Earth orbit, as we're traveling through the magnetic field, you design the magnetorquers to generate a small torque and detumble the satellite. But if the orbit is very different, then the magnetorquers won't be effective in this. And therefore, the client may not have magnetorquers. So it's not that they're not allowed. It could just be depending on the client, they may not be on board. And therefore, we'd need some other technology in order to detumble the satellites if they spin up.
I see. Thank you very much. And perhaps also coming back to the risks, you have mentioned the new activities that will be published in the near future. And we know that we have to discuss the requirements in our proposals. So which risks you think are worth really mentioning in the proposals, and what is really the mitigation that ESA is looking for those risks involved with in-orbit missions and with development of in-orbit technologies?
Yeah, I think, let's say for the specific activities, I can't answer that because they're still writing the statements of work and it's not concrete yet. But it depends a lot on the technology. But at system level, one of the things we're always interested in is to avoid collision, a risk of collision, because a collision can have a number of consequences. The consequence being debris generation or becoming a non-operational satellite. So maybe if for in-orbit servicing, if you're rendezvousing with a commercial satellite and you have a collision, aside from generating debris, let's say that satellite also becomes non-operational and you lose revenue. So really at system level, we always want to avoid the risk of collision. And then this needs to be flown down. So when we have ITTs on specific technology developments like robotic systems or rendezvous sensors or controllers, we're always interested in how these major system level risks can be supported by technology developments. So for instance, when you're building a capture system, I mentioned that to avoid collision, you could have this capture before contact type of requirement on board. So this is, let's say, the typical approach that we look for to when we issue ITTs on equipment, thinking about how the system consequences or the system risks can be flown down and mitigated by these technologies.
Mhm.
I hope that answers the question, Jakob.
Yes, yeah, absolutely, absolutely it does. And if you don't mind, I think we have some more questions, and I still think we have time for that. So we have a question from Błażej about can we use in small satellites some kind of solid fuel engine for re-entry?
I think yes. I mean, I'm not involved heavily in that area, so I know that there is my colleague Tiago Suarez and Sarah Morales. They're working in the other area of clean space in CleanSat on solid rocket motors and solid rocket kits for re-entry. So indeed, this could be something that could be adopted in the future. I think it's under study at the moment. Possibly that's a direction it'll go in the future. But yeah, I can't say much more. It's not my background. But Ajay, again, if you have something specific that you'd like to know, you can always email CleanSpace, and I can get Tiago or Sarah to write a more detailed response.
Great, thank you. I think we have just one last question from Krzysztof again about the recent success with the EMF-2 satellite and the servicing mission. What do you think about this approach that Northrop has presented?
So I don't know, let's say, more than what's written on Space News on the mission extension vehicle. I know that they went to the Intel satellite, that they've captured this. I believe they've captured it from what's written on through the one of the thrusters at the back of the satellite. This approach is something that we'd studied back, I think, in 2008 in other ESA studies when we'd worked on Cone Express or Mission OLEV. So some of you may have supported these studies, but we'd also with DLR worked on this concept of capturing a satellite through the liquid apogee engine. So for telecom satellites in GEO, they have these large engines to do the circularization burn on the geostationary ring. So they're only used at the beginning of life. And they're very large engines, and they fit quite nicely for capturing. So I think the approach seems good. It's very nice, I think, for the industry that Intelsat is interested and keen to procure these types of services, because it really shows that all satellites, you don't just need to discard them and push them out to the geostationary belt. You can really enhance and increase the utilization of these satellites by having another entity provide some sort of AOCS takeover. I'm not sure what's going to happen with MEV2, but thinking on debris generation again, I would hope towards the end that really the satellites are also pushed out towards the geostationary belt. So this could be a service that MEV also does. So it does station keeping on orbit. We know that. It's what they've stated. Once these satellites reach end of life, MEV may also push these out to the graveyard orbit as well. So they could be providing a multitude of services, which is very interesting, I think, to see how this progresses. And I think building towards the future, it would also be interesting to know if Intelsat will adopt features on board as well, like markers or other technologies to support this type of mission. This would be quite interesting. Could reduce the risk for a servicer, or reduce the cost as well for the client who's procuring this.
Mm-hmm. Great, thank you very much for this answer. And perhaps just the last question from myself.
Yeah.
How would you, for example, persuade or encourage the industries to get involved with the in-orbit servicing in general?
I think there's already quite a big involvement from Polish companies in orbit servicing. From ED Orbit through to Adrios now, there is quite a bit of involvement. And it's Polish companies are, let's say, have been involved in all the different technology developments in this area. So I think in general they do quite well. And for in-orbit servicing, let's see what happens for the RFI. There will be ITTs on this in the future, and I would hope we get some Polish companies following this and bidding for these. I wouldn't be surprised knowing that they've been heavily involved in this area in the past. So.
I see. All right. Thank you very, very much, Andrew, for taking the time to tell us about the clean space and its risks. It's been a pleasure to have you with us. And yeah, we're looking forward really to have more and more Polish companies also involved in this sector, but not also Polish companies, and making space really clean and sustainable, really, to be able to host a lot of new payloads in the years to come.
Great. Thanks very much, Jakub.
Thank you. Ladies and gentlemen, we have some issues with our next speaker, as Mrs. Kucewicz from AIRBUS was not able to join us. So perhaps I'll now give a floor to Kinga, and I think we'll move on with the rest of our program. So Kinga, the floor is yours right now.
Yes, thank you. Thank you, Jakub. Well, we are talking about risks and about sharing experience, sharing also a hard one. And my experience is that nevertheless, how much you try and how much you devote your time to prepare, for example, an event, always made go something wrong. So there needs to be a plan B, C, and even D. And I highly encourage everyone to plan a few backups for situation like that. Nevertheless, Katarzyna Kucewicz from AIRBUS Poland promised to record her presentation, and we will share that on YouTube for you find out what kind of projects AIRBUS Poland has, how it is to be a part of larger corporation, and mostly how to mitigate risk, how to work on the risk in large organization. And now I would like to give the floor to Paweł Ziemnicki. I know Paweł for already a few years. I think he was one of the first people I get to know when I joined space sector back in 2016. And he has an experience like, oh my, it's already 10 years in space sector, which not many people in Poland can say. Paweł is working in Allies Incorporation, and today will tell us more about Earth observation. So, Paweł, the floor is yours.
Thanks, Kinga. In fact, it was partly because of you that I started to be engaged in the industrial, let's say, space sector. Previously, I was concentrated mostly on astronomy outreach. And then I remember that I managed to become the writer of several articles on space industry in Poland for Polish Industry Development Agency. And this is actually how all of it started. So nice to meet you again.
Awesome, that's great to hear. And yes, our industry needs talent. So it's great that you joined this part of the force, I should say.
Okay, so let's go to the presentation. I will share my screen.
And just technical. Please
Yes.
Ask questions in Q&A. I know some people from MAXAR will join for Q&A session, so I can see in participants a few of them. So please ask questions in Q&A, whatever you would like to ask. It's the right part, and then some information that we forget about. So today all day it's in English, and we will have networking session just to give you all and ourselves the feeling that we are on the conference and there is a possibility to exchange knowledge and to network. And that's all from my side. I'm turning off my mic. Paweł, please do my.
Thanks. Good afternoon, everyone. My name is Paweł Ziemnicki, and currently I'm working as a Satellite and Space Technologies Division Manager at Allies Incorporated. We are representing MAXAR Technologies here in Poland, especially offering satellite imagery and the related products as well as services to governmental end users within our country. So today, satellite imagery is much more easily accessible than it used to be in the past. by addressing satellite imagery, I'm not only talking about, let's say, this freely available data like from Copernicus or Landsat, but we can also easily get access to high resolution imagery and very high resolution imagery from commercial providers. Satellite imagery is now an essential part of our everyday life, even though we not always think about it, that the data that we are using on the everyday daily basis is coming from the orbit. So satellite imagery is vital for predicting changes, any trends, as well as potential problems in different areas of economy, for example, as well as security and intelligence also. Having access to proper and reliable and also up-to-date satellite imagery gives individuals, institutions, government, but also entities a chance to mitigate very, very different kinds of risks, not only man-made risks, but also the ones that are the result of natural catastrophes or different disasters. So you have to have good knowledge. You have to have enough data to be sure that you are making good, confident decisions. So any decision maker or manager always needs to be prepared for the bad scenario as well. And if we are talking about the risk, we can define it as a function of how poorly your strategy might perform if really this wrong scenario occurs. And we know that it might occur. So be prepared for it. Have some backup options. And whatever you decide to do, whatever precautions or steps you decide to take, just make sure you don't block the Suez Canal. Here we see the Worldview 2 image of this famous evergreen container ship blocking one of the most important transport tracks for the whole world. This situation lasted for several days and cost a lot of money. And by the way, later during the networking, I can share with you the interesting link, a very simple online computer game prepared by CNN, where you can try to drive such a container on your own through the channel just on your computer. It's not easy, believe me. Okay, so let's go further. We will try to divide all the risks that we will be talking about today into two groups. So the first group will be related to military threats, national security, and the second part will be more devoted to civil use cases. For example, here on this Worldview 1 image, you can see many Russian Su-34 aircraft. This image was captured in the airbase quite near Ukrainian Russian-Ukraine border. It was quite hot there recently. Now it seems that the situation is getting more under control, and the conflict will hopefully not escalate soon. But it's always better to be ready for any scenario, and in order to be ready, you need to have good access to very reliable intelligence data. One more aspect about this image. Those aircraft are on alert, so they are very much ready to get into action anytime soon. In order to understand and address any kind of threats, first we need to see them. We need to be aware of the situation. So this is why we need high-resolution satellite imagery. It gives us extensive, detailed knowledge on any military-related activity in the neighborhood of the borders of our country. Apart from just the neighborhood area, due to access to satellite data through advanced platforms, the government can see not only this very near area of its own country, but can have awareness of the global situation. And this is vital for making good decisions as far as, for example, defense planning, allocation of resources, and assessments of potential incoming threats. One more example. This is the border between Iran and Afghanistan. The photo was taken in February by Worldview 3 sensor. And this shows the aftermath of the big tanker explosion. The security of the borders is actually vital for the security of the whole country. Earth observation satellites give access to the data about, let's say, hotspots, so places where this border crossing and migration concentrates. With satellite imagery and access to related persistent change monitoring services, for example, you can see where the new roads are built, where the new railway tracks are constructed. And apart from all of this, good intelligence here also ensures the continued flow of legal commerce across the borders of your country. So military, but also economic protection. this photo is interesting, and it was very popular on many websites just weeks ago. It was captured by Worldview 2, and it shows the Russian Delta IV submarine. It seems it was made during some kind of advanced exercise when Russians used some kind of weapons to prepare the ice to then be able to break through this ice. And when the submarine comes out of the ice, then it is able to use any kind of more conventional weapon. Needless to say, those kind of submarines are nuclear capable, so they are able to carry nuclear weapons. So with satellite imagery, you can detect, monitor, and counter such activities, as well as in a more general way, you can prevent proliferation of weapons, such as weapons of mass destruction or long-range missiles, as well as more conventional types of weapon. With access to satellites, you can also pursue the deployment and transfer of such kind of weapons. And as we can see on this slide, such imagery is also a good kind of evidence to show the general public, show different governments around the whole world if any, let's say, bad and potentially very dangerous activities performed by hostile country or some kind of rogue organization. Of course, satellite imagery is also a crucial tool for counter-terrorism activities. And this can be described with 3 P starting verbs, so prevent, protect, and pursue. With satellite imagery, you might identify terrorism-related activities, often in the very remote and hardly accessible areas. You can, for example, see the training camps or the roads used for smuggling any kind of guns or missiles. In this picture, we can see the results of US air strike performed upon one of the bases in Syria. It is the let's say a place where some members of Iran-backed militias were hiding, and those people had previously performed an attack against US coalition, US and the coalition personnel in Iraq. Satellite imagery is also always very useful to see how the area has changed. For example, because of any kind of explosion, airstrike, or different kind of attack. Here we see the example from Equatorial Guinea, and it shows the result of explosion at the military base. What is also very important is that satellite imagery might be used for protecting your own troops and your own equipment as well as infrastructure. The US term often used for such kind of activities is called force protection. How to do it? So with proper satellite imagery, you are getting access to the information about your weak points, soft targets, and you can also monitor your assets and see if they are threatened by any hostile action or group. So let's get to the civil part of the problem. As I mentioned before, satellite data can, of course, be used for prevention and also recovering after any disasters, and as well as natural catastrophes, but not only. For example, here you might see the WorldView 3 image of refugee camp in Sudan. Such images are very helpful for people and organizations helping refugees. With such data, you can, for example, see how those camps are growing, in which directions. You can as well see the, let's say, patterns of everyday life of inhabitants of such places, and thanks to those information, you can offer the let's say customized help for those people. And of course, having a good overall view of such camps is very useful for providing medicines, food, water, or some kind of education to people living in such places. Disaster response. Here you've got two images, before and after the big volcano eruption in Richmond Vale, St. Vincent. And of course, satellite imagery in such cases allows for resiliency and flexibility in the rescue and help that all the necessary personnel is giving to people hurt.
Paweł, apologies for disturbing your presentation, but we are running out of time, and I would still like to ask a few questions.
Okay.
And I know that Jason Sant and Kathleen Karika wants to join us for some Q&A. So if I may ask either...
Oh, okay.
Aislinn
I will
has
try to. Sorry.
just a few
Okay, so-
questions, if that's fine with you all. I will ask a few questions to take out of your presence as much as possible. I see Jason and Kathleen already on the stage, and we've heard a lot about defense and about crisis management. But then I'm thinking, how you like when you analyze your business globally, is more about defense, or it's more about civilian use and everyday use of satellite imagery? I don't know who can answer that question. And
Sure. Yeah, I'd be happy to address that question. First, thanks so much, Kinga, for having us on the conference. This has been great. So we really appreciate it. As far as our business goes, I would say there's a healthy divide between defense and commercial business. So our largest customer, no surprise, right, is the U.S. government, and we are the largest commercial imagery provider to them. We also work with governments all across the world, supporting them both on the defense and intelligence side as well as civilian applications. In addition to that, we have a large portion of our business that's focused on purely commercial. Everything from supporting insurance companies to some of the location-based services companies, primarily out in California. So we do have a healthy divide between both, and we're very confident that our capabilities, our existing ones as well as the ones we're launching here soon, will continue to provide the highest quality imagery for both defense and intel customers as well as commercial and civilian government.
actually, while Paweł was presenting, I've got some messages like saying, "Wow, what a good resolution!" So even in the presentation, it's well visible that you have just great resolution when it comes to your pictures. And it's nice you mentioned the insurance, because just a month ago we had Thursday gathering, so another event of Cosmic Hub, and there was a person from insurance industry telling us they are using satellite imagery to analyze how the disaster applies, how to address help to those in needs. And you mentioned governments around the globe. So since we are also, as Polish Space Agency, in touch with administration, asking them about their needs when it comes to Earth observation, what is your observation about the government? Are they using enough of satellite imagery? How that can be improved to help them to mitigate risk of everyday life?
Yeah, that's a great question. And my first response would always be, I always encourage the government to acquire more satellite imagery from us, and we're happy to.
But you're expensive. I'm not saying not worth it, but you're expensive.
Well, the briefing hopefully demonstrates the power of 30 centimeter, very high resolution imagery and what can be accomplished with it. It's not always the cheapest. We understand that, but we do work as closely as we can with different government agencies to really focus on helping them execute their specific mission as efficiently and as quickly as they possibly can. So on the defense side, obviously, we want to do everything we can for the variety of defense missions, really focused on keeping the warfighter safe, right? On the civilian side, we want our imagery to be used across a ton of different applications, as Paweł touched on in the briefing, but really to ensure that the government can take a sort of a holistic look on how to use the imagery and apply it for the countless applications that can be used, especially on the civil government side, as far as foundational mapping, addressing wildfires, you know, I know we're an issue for Poland, as well as a host of other applications. Now, with that said, the highest resolution pixels do come at a cost, but we do what we can to work with governments to meet their budget limitations and requirements.
If I could briefly comment on that.
Please do, please.
So yeah, we have to remember that together with MAXAR, we are having quite modern and flexible approach. I would say that probably buying pure imagery with this very high resolution might seem expensive, but there are different ways of getting access to imagery, and perhaps not always this pure imagery is the most important for the end user. So we are developing special services like for example the Secure Watch platform, when you can access very large archive of imagery, let's say based on your needs. You can download exactly those pieces of imagery that you need. And what is more, today the satellite data is not just pixels that you have on the image, but you can also have derived products, like for example digital terrain models or digital surface models, or even building footprints that you can see on my current slide. And with all of this, you can make good decisions, for example, about planning your city or prevention in case of flooding. So yeah, I think that what is most important here is that each case is different, and we are always open to discuss it with our potential customer.
Thank you. I know convincing public administration to be more digital, to use more digital tools, which means also satellite technology, is not easy. Polish Space Agency with some partners in Sat4Envy project built all knowledge base and workshop explaining how to use, how might be satellite imagery useful in administration life. If, for example, you meet someone who knows there's imagery and knows that you have great resolution, how you help him start? How you help him to go out of the safetyness zone and using old tools? Any advice on here?
Yeah. So the good thing about about satellite imagery is the ability to access it and exploit it through countless different platforms and GIS systems. So as Paweł had mentioned earlier, we do have systems, an example being Secure Watch, which is really gauged towards the not the advanced satellite imagery user, but really the beginner. And we've developed these systems to get potential customers and existing customers in and using the data as easily as possible. So if you could envision it, Secure Watch is really like an elevated type of like Google Earth or Google Maps, where the interfaces and the interaction with the imagery is very similar. And most people are pretty familiar with Google Maps and can go in there and can use the imagery And then as you build your skills, you know, you can begin to download it and start bringing it into other systems like ArcGIS or Envy or other GIS systems like that. In addition, it's very rare for us to put imagery out there without the associated training. We do have courses where we can work with customers where they can get GIS training, they could get imagery intelligence training, things of that nature. So we do a lot. We send a lot with the imagery to ensure that the user has the best possible experience when they're working with our data.
Thank you. I would like to ask also a question from a different angle, since I'm responsible for educational activities and we talk a lot with students to engage them into space sector, for example, concern either Earth observation, imagery analysis, or, for example, working in high technology in upstream sector. So I think my question is, if you can tell us a little bit how it is to work at MAXAR, and maybe a little bit about your other divisions, as well as maybe some advice for young talents, how to join MAXAR or any large company.
Yeah, well, and please, Kathleen, you jump in here as well. But let me just kind of give a quick overview. That's a great question, Kinga. You definitely caught me off guard from the other angle on that. I've been with MAXAR since 2001, with a small break in between. Yes, so the majority of my professional career has been with MAXAR, beginning with Earthwatch, then Digital Globe, now MAXAR. It's been an absolute great experience for me. I can't speak highly enough about MAXAR and all the great work that it does, both on the defense and intelligence side, but also on the commercial side. As far as the company has really expanded in the last few years, moving from just the provision of pixels, from just satellite imagery to bringing on teams that do a lot of services related work, primarily focused on the U.S. government, but also out with international customers, as well as an entire space infrastructure capability on the West Coast in California, where we're building not only Earth observation satellites, but also a long history of building communication satellites. So the company is so diverse now across different space-based capabilities. We really have a ton can offer to really such a wide variety of customers. It's really very exciting. But let me turn it over to Kathleen, because Kathleen's way younger than me, and I know she probably has a much different view on the company and building a career here. So over to you, Kathleen.
Thanks, Jason. And Kinga, thanks for the great question. So I think in terms of young professionals engaging in the space industry, there are so many opportunities right now. It is just incredible. One of the things I was thinking about as Jason was answering the previous question on how do we get our policymakers and our government officials smarter on what they can do with space. A key part of that is also training the young workforce or early career professionals on what they can do with space. So as they rise through their careers, they know that they have these tools at their fingertips. So we encourage we have different programs with universities to set them up with secure watch accounts or other imagery if that's of interest. We sponsor a number of hackathons that go on in different parts of the world. That's another great way to engage and get more experience with the imagery. In terms of the space industry in general, there are multiple ways, just as we've touched on in Issa's presentation as well, to engage with the space industry. So we all know about the technical aspect. There's also a policy side. There's a legal side. there's marketing and communications. So I think that we should be taking a whole of university and a whole of the private sector approach on all of the different ways that we can have students engaging in this really important market. I mean, we're projecting a global space market of $1 trillion. So not anytime soon, but coming up, and it's very exciting. So I would encourage the students seek out some of those international organizations. The Space Generation Advisory Council is a good one. It's based with the UN. We have a number of different organizations that are US based but have a heavy international component. SEDS is one, the Society of Space and SSPI, Space and Satellite Professionals International. On the US side, we also have the American Astronautical Society. So if this is of interest, we can definitely coordinate more with POLSA on how to get Polish students connected more. And I would say also young professionals. I know, as Jason pointed out, he's not in that category anymore, but just kidding. But we can definitely connect everybody up, and there's great exchange programs, great collaboration between NASA and ESA that I think we can definitely leverage more for our Polish friends.
Thank you. I remember it's already the third conference on risk engineering, and during the first one, Professor Malinowska gave me a chance to speak about risk that I recognize, and one of them was lack of mentoring, because I remember how frightened I was that I will choose the wrong career path. And even though in my work I keep telling everyone, you have to test, you have to try different roles, it's still frightening to do the wrong step. I saw Jakub, so I know my time is ended up. Thank you everyone for joining us on stage and answering some questions. And thank you for a very interesting presentation of real case, real examples of Earth observation satellite technology usage. And I hope we'll meet again.
Thank you, Kinga.
Thank you so much, Kinga. Yes, thank you.
Yeah, I also hope there will be time to speak again. Just one more sentence. The satellites, it is, as for the satellites data, it is not only about the resolution, but also about multispectral data. And this is what truly gives us lots of information. So I hope there will be more time to speak about it as well.
Thank you. And I hope you will stay for networking. And if anyone has some questions, please post it on chat.
Yeah. Thank you very much again.
Thank you,
Jason and Jason. It has been really a pleasure, and the pictures really that you have shown is amazing. And I surely hope that they will help to mitigate many risks for the end users of this data. So thank you once more. And with that, we are moving on to our next panel. And exactly in this panel, we'll be talking about how to turn risks, as the risks are present in all of the space projects and endeavors. We, of course, want to mitigate those risks by turning them into opportunities. So, for example, making a new product that can really help to address the risks that we are facing. And for that very interesting panel, I would like to welcome our great guests. And with us is Brian Dean, a CEO of Dragonfly, who has extensive experience in creating software and hardware space systems. It's great to have you, Brian, with us. I think you'll join the stage in a moment. I also see Shashank Govindarai, who has more than 10 years of experience in design and development of software and robotics systems. Shashank is a member of a space applications services company, and he's a team leader and robotics software team and project manager. It's great to see you, Shashank, with us.
Thanks, Jakub.
Yeah, and I see Brian here with us as well. It's great to see you.
Yeah, hi. So I was getting the camera and mic on. Nice to join you.
Awesome. Yeah, everything is clear. And also we have with us, last but not least, Przemysław Radzik, a telecommunications engineer and also project manager and space enthusiast. He joins us from Thorium Space. He also has experience as the YGT graduate from European Space Agency. It's great to have you with us.
Great being here. Thank you for the invite.
Thank you very much for joining us. And this panel is moderated by Kinga. So Kinga, I'm giving you now the floor, and have a great talk.
Thank you. Yes, some more questions from me. And while I ask the first question to Kuba was about the power of networking, I must admit that I was connected with all of you from through the channels that I did not expect. Of course, Przemek I know from Polish Space Professionals Association because we are both on board there and discuss a lot, but I didn't have a chance yet to understand how you see risks and how you see opportunities. So my first question is about your perspective, how you understand those words, risks and opportunities. Let me ask, start with Brian. So how you understand those words?
Hi Kinga, yeah, nice to join you. So I'm gonna limit it to discussing let's call it technical or project risks for now, rather than company or commercial or legal, obviously, which is the scope of this conference as well. But in terms of a space mission, a risk is a potential failure that can take place during the design, the build, transportation, the launch, or the operation of a spacecraft in orbit. And during the period up until launch, the failure can result in cost overruns, schedule delays, potential loss of critical function of the spacecraft, and these sorts of things. During and after launch, obviously, the failures can result in a partial or complete loss of the spacecraft, or possibly a function of the spacecraft. And depending on the severity, this can lead to a total loss of the mission, or possibly a reduction of performance or the lifetime of the spacecraft. So as engineers, we try to identify and design around and remove as many risks as possible. This is our goal in life. So that'll be my first take on it.
Thank you. Shashank, any thoughts from your end?
So hi, Kinga. Yeah, can you hear me okay?
Yes, perfectly.
All right, that's good. Well, I think Brian already kind of summarized quite a few aspects here with respect to technical risks. Indeed, I mean, I would also categorize risks a few more aspects related to technologies that are developed by partners, especially in consortium-based projects, which is could be the case in many aspects. Many people, many companies coming together to put together a system, and in this case, integration is always quite critical. And that level, we see quite a few risks because each one goes around with their own development quite often, quite well, because they are, let's say, quite good in what they do, at least in their specific technologies. But putting them together to work in a very short duration of time to make it really work smoothly, interface of software, be it software, hardware, mechanical, electromechanical, so many aspects. We work with a bit of planetary rovers, robotics, orbital robotics, and there we see it's a bit of an applied research domain at the moment, not yet so mature, let's say. The risks there are that things do not work as expected, and we take a lot of time iteratively to come up to a fully integrated system, and these risks are seen again and again, and mitigation is still, let's say, ongoing to find, let's say, good ways to come across with good solutions to this problem.
That's interesting what you say, that the risk the same. I understand that the same risk happen all the time again and again. That's interesting. Przemek, any thoughts from your side? What is risk? What is opportunity?
Yeah, right. Thanks. We heard a bit about technical risks, but we cannot forget everything else that goes around a project. But for the sake of starting this conversation, I'm going to be a bit more general. I want to say that a risk is, broadly speaking, anything or any uncertain event that can be deteriorative effects to your project. So that goes all the way from personal to technical. But those risks, they, if properly mitigated, they could potentially turn into opportunities, which can be defined as something that has a positive effect on the project in turn. So just being a bit general here.
Thank you. Let me explain why I started with that question. I remember when I was preparing my first proposal for the project, and of course there was a bunch of pages asking me to analyze risks, and I thought, okay, I will just copy and paste from some different project. That's why something what Shashank said hit me, that I might be not the only one. But then I analyze what I actually check what risks means, and I check some PM books and of course the dictionary, and try to understand how I should explain my risks. And that was an educational project, so most of them came down to people and managing people. Of course I had also some technical risks that I had to that I spotted, but most of them were around managing communication people. So I thought starting with how we understand risks would be a good start, just so we have the same base. Anyway, that's also interesting that I think it was Brian who said that from engineering perspective. And that's interesting that we can actually see that maybe lawyers will understand differently. Maybe project managers, the one that have no engineering background, will understand the risk differently. I'm also curious about your risks. I think Shashank and Brian already started a little bit telling us about risks that they spot. And Brian, you run the organization, so you have to take care about your employees and projects. Can you share with us some risks, maybe just one story about risk that you spotted and how you handle it?
Yeah, well, I mean, Dragonfly Aerospace is a new company, and we started at the beginning of 2020. We've got quite an experienced team. The South African space industry has been going for quite a long time. Sort of started in the 90s and been building a number of missions since then. But at the end of 2019, it all came falling down due to financial risks and staff risks as well, in terms of not having the income that you need to support the workforce that you have. So yeah, before 2020 and 2019, I was working for a company called Space Advisory Company, which is part of SCS. Anyway, this company, it closed down at the end of 2019, but we had quite a strong team, with many years of experience in us, and so there was a real risk at that point of a loss of the space capacity in South Africa, because as everyone, as you know, in Poland and other countries where you're based, it takes quite a long time to build up a critical mass of skills in your industry. and it comes from investing in university programs, investing in startups, investing in government programs, projects for people to build up their experience on, and this doesn't just happen overnight. So what we sat with in South Africa is this situation where we have the potential for a large bulk of the engineering capacity in South Africa to just disperse, and there's always greener pastures. It's not like the space industry is the most reliable industry in terms of business. It's pretty good right now, but it's not always been like that. And once people head off into other industries, engineers who have space experience head off into financial industries where they'll get paid better, and telecommunications where they'll probably get paid better as well. You're unlikely to get them back again. But you can't just take somebody out of one of those other industries and stick them in the space industry and say, okay, go do this job, because their experience is what makes them valuable. And it's exactly this topic. The experience is knowing what's gone wrong in the past in order to try and not do it again. I know, Shashank, you said you want to try avoid doing the same things again. That's a funny one. I mean, it's true. I'm not supporting you there, but in general, we try not to do the same things twice, and that comes from experience. So anyway, we sat in South Africa with this situation, and the company, all shut down, and we decided, a bunch of us, the senior engineers, we decided to try something different, and started this new company, and it's grown very, very fast, and we've trying kind of a new space approach, the new way of thinking, and also the opportunity to kind of promote South African engineering more widely to the world. And that's so far it's been quite a success story, and I'm pretty happy with how it's gone. But it took the financial risk of collapse, for the opportunity to come out, and you just got to take advantage of those opportunities when they arrive, and make the right decisions at the right time. I mean, now I'm thinking business-wise, not into technical anymore. I guess that same philosophy will apply to other risk areas as well. But recognizing the opportunity is important, and then committing to it and pushing really hard in that direction is fundamental to turn that sort of situation around.
I see we have common goal. My goal is to promote Polish engineers and Polish know-how in the globe. Yours to promote South African engineers. Two questions, just to clear things out. Can you tell us what Dragonfly is doing? And that's the first. And the second, you mentioned South Africa. Honestly, I'm super curious how space sector looks like in South Africa. Can you tell us just a little bit on that? And Shashank, Przemek, if you want to add something or comment, please just turn on your mic and let's discuss.
Sure.
Yeah, so in terms of South Africa, it's Dragonfly Aerospace, we do satellite imaging. So primarily a visible and near infrared range. We're working on a couple of nice big projects at the moment, some high resolution images. In the previous talk there was a point made about spectral bands over resolution. That's obviously an area that we're putting a lot of emphasis into. We're doing a project with a company called EOS Data Analytics at the moment. We're providing a 1 meter resolution imager with 11 spectral bands, really targeted. I mean, this is primarily looking at agricultural focus, but that same information is useful in the disaster monitoring and in many other applications as well. Once you're able to image in multiple spectrums, then there's an extra layers of information that are there. So we've got a nice project working on that at the moment, and we're also doing a hyperspectral imager together with Nanobionics at the moment. A mission that's going to launch a couple of months' time, so that's quite exciting. And obviously, in the mountain, hyperspectral just takes it even further. So where we're doing 11 spectral bands at 1 meter resolution. With our hyperspectral, we're looking at 30 meter resolution, 32 meter resolution, and there we've got 160 spectral bands on that imager. So this is all in the visual range, but you're chopping up the spectrum into really narrow slices, and each one of those pieces, each one of those spectrums has a piece of information, and when you're able to now compare the response of the planet in these 160 different spectral bands, each one has a different bit of information it's giving you. Okay, so that was just the intro. I'm sorry, I'll try to keep it short. So we do satellite
No,
imaging.
it just shows that you live with your projects, you live with them and your company, and I think it's a good sign. And honestly, in space sector, I love space sector because I meet so passionate people, and it's so easy to get into their passion and all those stories. So it's a good sign.
Yeah, so in terms of the South African space industry, pretty much imaging, Earth observation imaging is what has been the focus in South Africa. It started with a first satellite that was launched in 1999. It was called Sunsat. It was built by the Stellenbosch University, and it was pretty good. The whole satellite was built from scratch by South African engineers at the time. Actually, over quite a long period of time, there were many master's students who did little pieces of work on the satellite as various pieces. So a lot of people involved in the satellite, but it eventually launched in 1999. And it was very successful. It was a 64 kilogram satellite, and I think it had 12 meter resolution imaging. And it has actually been subsequently recognized that at the time, in 1999, there was nothing in that class of satellite with that performance of images. So it's kind of the best of its class at the time. So that was pretty cool. And since then, it's been a progression of the technology from that initial base. Satellites getting bigger, images getting bigger over time. And the most recent satellite was over 400 kilograms and sub-meter imaging. So it's progressed from humble beginnings, to some pretty impressive satellites, and more recently. Obviously, like I said, the microsatellite capability is primarily based in Dragonfly Aerospace. There was 2 companies that were struggling in 2019, and we pulled his various staff from those 2 companies. One was called Space Tech, another one was called Space Advisory Company. But the South Africa is growing, so that's microsatellites pretty much all inside Dragonfly. But if you look at the nanosatellites domain, then the country is doing really well in the nanosatellite domain. We've got a great company called Kucewicz, who's building attitude control systems for nanosatellites. Hypernova are building a propulsion system for nanosatellites. There's CubeCom, who's building radios for nanosatellites, and a number of other companies as well. So it's getting to be quite rich industry. Probably more than 10 companies there now, which maybe in the rest of the world doesn't sound so impressive. But in Poland, I'm sure you recognize that getting 10 established companies that are profitable in the international market is challenging. And it's taken a long time to get to that point. the first satellite was built by a university, then it was spun out into a company called Sunspace, and pretty much every company that exists in South Africa today is in some way a child of that first company called Sunspace. So it's kind of the way that the industry grows up over time and diversifies, that leads to a more stable and healthy and robust industry.
Thank you. Well, I know that having 10 well-established companies, it's a challenge when it comes to the policy. And it's nice that you speak from a startup perspective, because right now we are discussing a lot how to support startups, how to be more risk-taking nation. I mean here by Europe to support new space. And Przemek, you represent startup, and of course our association as well. But then, can you tell us a little bit from Polish startup perspective?
Well, yeah, indeed. I'm currently working for Thorium Space. It's a startup based in southwest Poland. What we mainly focus on are radios, so the telecommunication side of the satellites. What we want to do is put high throughput radios on small sats and nanosats. That's by designing the flat panel antennas. However, if we want to talk about risks, I can tell you a little story about that. As you know, and as it is with many small companies that you can see arising, there is a big ambition to do lots of things at the same time, and to do maybe a bit more than you're capable of, kind of. So the risk is that you have a given amount of money and time, and you have to make the assessment whether or not, or how much of the technology you can do yourself, and how much of it you should rather buy or partner with somebody else. And this is something that I've noticed when I joined Thorium Space, because other than the radios, the ambition is to put satellites in orbit as well. And remember, we're only 3-year-old startup, right? So that's a lot of heavy weight on our shoulders. So I've identified a few risks when I joined, and not surprisingly, some of them, came to be, so occurred. One of them was pretty much a personal one, and that comes back, Kinga, to what you said. In my opinion, communication and pretty much people are a kind of bulk of risks of what you should be analyzing and what is important at your company in the end. So what happened, I need to be a little vague here, but I'm going to try to be as specific and as vague as possible. But what happened was we kind of lost a competence, a critical competence that pretty much what could happen is it could potentially stop our company. But because we identified that beforehand, we kind of foresaw that could have happened. We also partnered with somebody else. We decided to, hey, maybe this is a bit too much. Maybe we should just do this much and give that portion to somebody else that we know that is a very well established company in Poland, that they have extensive experience in that range of competences that we are now lacking. Maybe we can create something out of it. And a year after, currently, our partnership has grown. We currently start in a number of different projects, not only this particular one to build this transponder and put it on satellite, but we're also working on a different projects. So in the end, there was a risk that became an opportunity for us to grow both of the companies. So my perspective is that when it comes to small companies, we should really focus on the one thing that you really want to do, and then build up later on.
That's great what you said, and also quite scaring for me. I'm kind of person who always take too ambitious tasks or too many tasks on plate, and sharing the responsibility, sharing the project. Wow, how you do it? Like honestly, how you do it?
Well, I mean, I know you for quite some time now, and I know that it's difficult to kind of call you sometimes in the evening. So, I mean, you have to put a stop somewhere. But it's not about your time. Well, it is about your time because you don't have to. You cannot be stressed. When you're stressed, then you're not working properly. But it's also about the resources that you have. This is all limited. You cannot. Well, you have investors on the one side that you need to make happy. You have your team on the other side who wants to see success, and you have your own goals. You want to be profitable company. You have to decide at some point that, okay, this is going to be my core business, and this and that I need to kind of either procure or do with partnerships, because otherwise your risks go through the roof and they probably overwhelm you.
I think you're right. That's my logic part. But what I want to say is like, no way. I can handle it. Anyway, Shashank, any observation from the risk, any story you would like to share, or maybe an advice for me or people like me?
Well, when Jakub invited me here, it's also because we were collaborating a bit in the last couple of years with Jakub and in a project which is from the Commission but managed by all the space agencies in Europe. So ESA, the Italian Space Agency, French, and so on, German. So fundamentally, it's a series of 14 projects managed by all these projects. I mean, managed by all these agencies to do with on-orbit servicing and planetary exploration. So it was really to look at technologies that could be developed with high risk, of course, high risk, high reward approach for let's say lunar construction, exploration in hard to reach areas. I'm not talking about the on-orbit servicing because that's not the one I'm focusing on today. And we were coordinating it. We are coordinating it. This week is the last week, so it's just in time. Let's say we're writing the final reports, but yeah, it was a 2-year project. Started really well. Many partners, 9 partners across Europe, LSI companies, and so on. And then, of course, we all ran into this problem last year, which was kind of in the middle of the project. That was this pandemic that really stopped us from working literally in our tracks. And why was that? Because we had about 4 robotic platforms that needed to not only logically cooperate. The idea was for them to physically cooperate, to move objects together for construction, assembly, and demonstrating these kind of capabilities. Now we are in the middle stage of the project. We planned for 3 integration sessions before the demo. That kind of was the objective or the plan. We were in advanced stages of development, and when this happened, of course, we had to come up with a way to continue working on very strong control related problems, apart from perception and the planning, which is anyway complex by themselves in multi-agent systems, and still continue with the scope of the project. I think at some stage, at a very early stage, we realized that when you have robots physically interacting but cannot be in the same location, that's like, that's quite a bit of a problem, right? That we have to demonstrate something or develop some technologies when that situation does not exist. And of course, the initial idea was to just put the whole thing on pause and say that, okay, when things open up, we'll try to get back together in one place and start, putting things together. And essentially, the approach that we took was to try and find an opportunity here. Is that typically once robots are well programmed and tested, whether they fly to another planet or in a different location, even in commercial applications, we could control them remotely. But here we're talking about development, even in the development stages, to work remotely. And that was not something that we've done so much, especially across so many locations. With 4 partners across Europe was where these robots were present. So we took this as a challenge, an opportunity to kind of involve all the stakeholders here to explain, to iterate on multiple plans on how we could approach it. And in the end, we did manage to work on really control-related problems by putting up some mock-ups where another robot would be acting on the same object, replacing that with commercial robotic manipulators instead of mobile robots. Trying to really find some ways to, of course, with all the remote connections that were required, multiple camera views. Partners had to be very much agile in the sense of it could be that today or this week we have a plan that things are ready and about to be tested. So we needed personnel on the floor with the robots supporting us, who are connecting remotely to test software, maybe algorithms, be it perception or control. So this really needed, let's say, a lot of plan ABCs to go along in parallel. Everybody had to be updated about it. So we didn't do anything very innovative apart from just managing risk, and just talking to people, trying to get everybody on the same boat, trying to understand if a solution works, to work on solutions remotely. And in the end, I think we did manage to tick most of the boxes that we planned for. While we never got to really work together on one location, we did find one slot last September when things were a bit more calm, and we managed to meet and really use that opportunity to advance a lot. We picked up our lessons and went back again and started working remotely again. So I think in the end, what we realized is, as an outcome or the opportunity or something that we would like to talk about in the future, is that not only that the fact that we can integrate systems remotely, but we can even develop them, integrate them from different locations, and not just operating that remotely, which is anyway the case. So this is something that we want to, in the end, use this as an opportunity to promote this in future projects. Maybe we can even be more cost effective by following this model. Rather than traveling into all the time, bringing heavy equipment together.
Please don't share that with European Commission, because then they will all travel budget, let's cut it. If that came out of the project, let's cut travels. And I know from my perspective, even sometimes creative brainstorming, it's easier to have once we meet in one place. It's also risky, especially right now, to travel and to meet in one place with more people.
Yeah, indeed.
And then something that you say, that you had to keep updated and communicated with all the partners. I know that's something that many people struggle with, like how to communicate. Should I do just a webinar, or should I just send a memo? Any advice how to handle communication in a time of crisis?
Yeah, well, I think, transparency is key, especially when you have a lot of partners who want to know what's the next approach. Let's say the next step, which is anyway unknown. There's uncertainty. We don't know what's going to, what kind of access to labs are available. We work with universities, companies, research centers, so it's a mix of partners from different backgrounds, which makes it even more interesting. I think in the end, let's say tools can be used, many tools can be used, but without picking anything uniquely, I would just say having the plans really clearly put down in flowcharts, different checkpoints, different preconditions that just say that if this condition is triggered, this is what would be the next course of action, so that everybody has access to that global flowchart of sorts, state machine flowchart, anything you want to call there, or whatever the technique might be. But really having this visible to everybody, not only the technical providers, but also the stakeholders. So both of them have the same view in the end. Information is flowing across quite clearly, engaging them quite often. So alternating between going to partners, project partners, and coming back to, let's say, back to the stakeholders really to explain what's happening and what are the expectations, conveying that back to the partners. Having this back and forth of information constantly, even if it's a bit let's say there are some overheads at that. I think in these moments, those were the critical steps that helped us get through and continue with the project rather than putting it on hold. Yeah.
Thank you. I had an information that my camera died, so just to confirm, I'm still here with you. I hope it will work fine now. Anyway, so you mentioned you start, Shashank, telling us a bit about tools. Let's check that one. Do you have any tools or any advices how to motivate people and how to keep them updated? And well, I need to ask how to evaluate risks. We start with a joke that I want to just copy and paste some risks from other project. How to motivate people to not do it? Because I know from my own perspective that then you can miss some risks and you basically get into troubles. So guys, any advice on tools? What kind of tools to use? Brian, you want to start?
Yeah, I don't think the tools are so important more than well, firstly from the philosophy. You know, particularly as a commercial company, you know, I've worked in other domains before, you know, this purely commercial route now. But I mean, at the moment, you know, risks can lead to the death of the company. You know, as we were saying earlier. So you know, you definitely don't want to be copying and pasting when a risk can lead to the end of the company. So you know, you certainly need to analyze the risks. You know, in the end, there's multiple tools for this. I've used multiple tools in the past, but in general, obviously satellites. If we jump into the technical, you know, the satellites are mechanical and electrical machine primarily, obviously software as well. But you know, in terms of the electronics, you know, parts trace analysis is something that's really important to do. Failure modes analysis is really important to do, and single point failure analysis is really important to do. And the exact tool that you use for that, it's not so important. You can do it in a spreadsheet, or you can, you know, I've worked with commercial tools that facilitate this as well. But in the end, it actually requires the engineers to go and analyze their designs, and that's the time-consuming and hard work is then analyzing their designs. How you capture that information is less important. But you know, in general, that's our approach at a technical level. And you know, when I said, you know, the death of the company, you know, the technical thing can lead to the death of the company. Obviously, there's company level risks as well, in terms of, you know, in finances, and I think somebody had said earlier as well, you know, losing a key employee is really a challenge in a startup, because if that person's got a key skill, then you know, that's and we've certainly gone through that already, and you know, we're lucky to be able to survive that risk. Yes, I mean, in the end, you know, I don't think the tool's that important. Identifying those risks, and then you know, identifying the mitigations from designing around them. You know, in terms of the systems that we develop, we try to remove any single point failures, and that can happen at a company as well. I mean, the example did earlier was about having no single point failures at a company level. You know, not having that one key person who is the only one who knows anything is a single point failure. So, you know, it's the same thing for the company and for the satellites. And we try to remove those as much as we can. And again, I think I'll start with a technical mitigation or solution, and then I think it applies to the company as well, is that if you can't remove a single point failure, then, you know, you aim for graceful degradation, which in a satellite is, you know, continuing to operate is not quite maybe full performance. In a company, it would be the same thing. Continuing to operate, maybe not quite full performance, but you're not having a gap in that area. And whether the area be a personnel or finance or facilities, it's the solution is the same, I think.
Thank you. Przemek, I saw your smile when Brian mentioned the philosophy and the organization. So why?
Yeah, I mean, no, because in this conversation, I always hear you saying the copy pasting of risks, and that's just so funny. I'm sorry, but I mean, what I mean by that and by that smile is that there's some meta-analysis to be done here. I don't think, I agree with Brian that the tool is not really important. What is important is to create the atmosphere and philosophy within your company to kind of nurture and cherish people who say, hey, I found or identified a risk, and then look, something might go wrong. And, really, really show them that that means something and that you can take action on it. That, look, okay, what can go wrong? What can we do about it? Create a risk master plan or a risk management plan, see what can you do with it, and take action as soon as possible. Now, if you're preparing a proposal, as you mentioned, Kinga, that's something else, because if you talk to people, if you talk to your team and say, hey, I need you to do a risk analysis, and they're going to be like, yeah, but that's super boring. I'm just going to copy paste that from something else. It cannot work like that. You really have to show people why is this important and what they can use it for. And then, of course, what Brian you said, the tools or the design philosophy within the spacecraft, whether or not the robustness that you want to achieve within your specification, that's a key component of it. Once you sit down and then do analysis of, say, communication link or the EPS system, or choosing components for your mission, etc., that is also should be in your risk management plan as well. But really, you have to educate people on why is this important and what can happen if we don't plan for every bad option.
And that's why we are meeting here today, to educate and to tell everyone what can happen if you don't analyze and mitigate risks. So Shashank, am I the only one who copy and paste risks?
Well, that's it depends if you're in a proposal or if you're on a live project. It depends on that. If you have a proposal with very little time to write something, well, it could be the case. But in a live project, I would recommend to avoid doing that, because it impacts the project itself. But I think one thing on the tool, just a very general comment, is, yeah, the tool can be anything, but with today's style of working, I would really not work on exchanging, static files or spreadsheets if possible. I think just pick a tool, whatever the tool may be, but as long as it's sitting in a cloud or, some server where everybody can see what's happening live, as you're updating it, as people are commenting on it. So that documentation should allow discussion. Yes, sharing PDFs and Word documents and spreadsheets, static files, I think hopefully the time is people stopped using that for being more efficient and more discussion oriented. As long as that's there, I think any tool, any technology, be it Google Docs or Teams or whatever it could be, can be great. Really, that would be one general comment.
Yeah, I've got a comment on that copy and paste story. Like I said earlier, what I rely on in our team is that I've got guys who have done it many times before, and they know which of the areas to avoid and which of the areas to really think about. And certainly looking at the risk register from another project is useful. So copy and pasting it without thinking about it is not useful. But looking through and seeing, hey, what are the types of risks that people have thought about? Is that relevant to my project? to my mission, or to my company, and learning something from that, because there's a vast knowledge that is gained over multiple projects, and as the first, if you started out on your first project and, like you say, you asked to do this exercise, you may not be able to think of things that, that somebody who's gone through this exercise many times before has. So there's definitely an advantage to it, but you just can't do it casually. You have to think about what you're reading and ingest, and then rather apply to your project.
Tricky question. How often you evaluate your risk plan of the risks? How often you make a comment, okay, this risk didn't happen because I did that and that? When we are talking about using it in the future, and if we lose, for example, someone who was in that project, I think that's helpful. Not that I'm not saying I'm doing it, I'm saying that might be helpful. Do you think so, or not really? Because we all remember. Przemek?
Oh yeah, but that's just what Brian said, that you really need to look back not only at your risk registers from previous projects, but also at your current risk register. I mean, for me personally, I cannot lie, I would like to do it more often. But that's kind of the definition of a small company. A project manager is a very loosely defined term here, if I may say so. But yeah, I think there is a great advantage in understanding what happened and looking back at it, because only then you can, learn something from it, whether or not that was a good analysis. And then, okay, is there a possibility of that happening again? If so, maybe that can be applied to another project. But I think what, for me, a project manager is, in essence, is a really sad person who pretty much sees all the risks. But to be fair, that's really what I think. Like, that's your main objective, is to be looking at risks and trying to identifying them and then communicating them to either the board or the stakeholders or your team as soon as possible. And there's nothing, nothing negative about it, even though I see people thinking about looking at you telling them, hey, look, but that's a potential risk to the project. And people sometimes think that, no, you're just being negative. I'm not being negative or positive at this point. I'm trying to see and find solutions to turn that risk into an opportunity. So therefore, you should do it as often as you can.
So how often is too often, and how often it's enough often? Szaszak?
Well, I think...
How often analyze risk registry?
As a general thing, I think at the end of any project, we always sit together with everybody, that, with the management, with the team, to really analyze properly on what happened, because especially to estimate efforts for any particular activity for our next project, that what we pick from, risks or overruns or complexity wise, we really need to analyze that so that we don't make the same mistakes again. And on that aspect, I think we're doing quite well. But during the project, when things are in a very peak moments, when things are going on at full steam, really at that moment, really to sit down and have the discussion amongst the list of priority items gets a bit difficult. But at least the project manager of any of these projects should be in a position to spend, some time every milestone, I would say, at least the critical milestones, to analyze this, because because there's really no going back. It's a one-way forward. Projects move forward only, right? So I think taking a moment to at these milestones to document them and even share them, even if it's not read by everybody, it could be a few short points to really highlight in a priority list, and then sharing that to everybody in the team or whoever's working on the project. some might pick it up, some might, it might get lost in some emails, but nevertheless, having that by the project management level will be quite important from my perspective.
Thank you. I would like to start a round of final thoughts, just because we are running out of time, and then I would love to have with you also some networking, which will be in different section of this platform, so with the tables that you can join. But let's start maybe as the panel started with Brian. Any final thoughts on risk and opportunities, how to manage both?
Yeah, I mean, look, risks, like kind of a cliche, but risks is an opportunity to improve. You identify a problem area, and when you design around it, you're making your business or your design better. So it's actually a positive. I know that we talked about earlier that people will go roll their eyes when you ask them to do a risk register because it's boring, but in fact it's fundamental. In terms of risks and opportunities, the whole new space industry is built on that premise. The traditional space is conservative, and certainly in comparison to the new space industry, a bit slower and a bit more expensive in general. What's appeared in terms of new space companies is companies who are willing to take on the risks and turn them into opportunities. If I think about things like the electronics that we use, we primarily use, and it's not just Dragonfly, throughout the new space industry, people are using commercial electronics as opposed to radiation hardened electronics. And there's some tricks that you have to play. You got to design around the issues because radiation is real and doesn't cease to exist when you apply a new company philosophy to it. But you can design around those risks, and you can suddenly take advantage of the latest technology, the latest performances, and in fact even reliability, because commercial components in general are more reliable from a mean time between failure point of view than a space component, which is never gets the same amount of usage cycles as a commercial component does. So there's many advantages to that, but it also comes, that itself comes with its risks, because now got all these new space companies and they're throwing up hundreds, thousands of satellites into orbit, and this is now creating a new risk, which is colliding with things in orbit. But then at the same time, new space satellites tend to fly lower and tend to deorbit much more quickly than the traditional space missions. So there's different things about the new space approach. But I think that if you measure your risks and you account for them and you design around them, you can achieve things. And that's the goal that all of us have, I think. So yeah, I think that's it for me.
Thank you. Przemek, would you like to add something or share your own thoughts?
Yeah, it's really interesting to see the new space market grow. That's both a risk and an opportunity from what Brian said. So let's hope it's gonna turn out well. But just to maybe sum it up, I think what is important to understand is that something bad or a risk is going to occur whether you want to see it or not, and then it's just better to foresee that and identify it first, so that you can in turn turn it into an opportunity. Thank you.
Thank you. You said about new space, and you are in new space, and I'm sorry, I cannot not ask you how is the shift from ESA, large corporation, large organization, I should say, with, I imagine, well analyzing risks and being focused on the risk to mitigate them, to not waste any taxpayer money, and then going to new space. How is the shift?
Well, that's really interesting. I mean, the shift is only in how you define the position, but so ESA or any large integrator or the old school kind of traditional space business, they usually under schedule time and under finance projects, of course, but that's normal for even new space companies. But what they do is that they really take time and effort to work around risks that they have and mitigate those risks really well, so that they finish with the product that they wanted to have in the first place. For us in New Space, and what actually happened at Thorium is that because we're smaller, because the costs associated with the projects are smaller as well, we could make changes more radical to the scope of our project that was in the beginning. I probably shouldn't say specifics about that, but I can tell you that what is going to fly next year, in the beginning of next year, is radically different than what we designed in the first place. That may be because of a few things. Maybe we have not identified risks at the creation of the company, that, hey, probably this solution is not the best, maybe we should go somewhere else. But also because of that, and because we're smaller, we could adjust to that, and we could change our project to still kind of fulfill some of our needs. So I think being smaller gives you the agility to make more rapid changes.
Thank you. Shashank, Jakub, who connected us, is texting me that you should share some video, but because we are lack of time, if it's possible, please share the link to the video, and please share your final thoughts.
For the video, I think it's still not yet online, so it has to have it locally. I think it's fine. It's just it's about the project and so on, but I think it's maybe not totally relevant here at the moment. But answering your question, I think on the risks and opportunity, I think if there are some certain significant risks, I think the opportunity is to try and see how your team or your company reacts really, and how that to find that as a moment, because a risk is real. If it comes into play, it puts everybody into a position to find a way to overcome that. And this is a moment to really analyze all the preparedness, all the documentation, all the discussion on how we manage it. So I think that's the opportunity to take out of, let's say, large risks. And I think, like Brian said, I think in the beginning that you had to overcome certain challenges of the initial phase of your company, and then reformulate a new plan and a new launch to your company. And I think that's the response, and that was a good outcome, I guess. And that's the opportunity, in my opinion.
Thank you for sharing your experience and your thoughts. I made notes during our discussion just because you share so many advices, and I think I will promote them with my team and the organization. Thank you again for the discussion. I would like to invite Jakub on the stage just to tell us maybe some final remarks from today's conference.
I'll just like to say that this can lead to death of a company. I think it's a great statement that shows really that we have to collect the risks, manage the risks, and think about them at every stage of the development, regardless if that's our company or a project. And what Shashank has also said, that we should do it quite often. In most cases, the tools doesn't matter, but what matters is really translating the risks to all people involved, both stakeholders and the people in the team. So I think that really makes a great summary of our conference, that it's really great to promote the awareness of the risks, because they exist both in upstream in in-orbit servicing, as Andrew has shown us in the beginning. Also, you can make educated decisions based on the data from downstream when you have a lot of risks on ground. And finally, in the day-to-day work of a project manager, this is a normal situation to just have those risks. So yeah, I really hope that we can talk about them more, and always try to think about how to turn those risks into opportunities, into new products, into new opportunities for new business, and to grow our companies and industry. So again, thank you very much to all the speakers, to Shashank, to Brian, to Przemek for participating in this panel, and also to Andrew and to the team from MAXAR and Paweł. Thank you very much for joining us. And right now, we'll move in a couple of seconds to the networking session, to the tables. So please stay with us, and see you till next time, because it was the third conference. I think the fourth one will be held both by POLSA and AIRBUS next year. So we invite you already to the next session and to our events of POLSA and Cosmic Hub, and also Akademia Kozminskiego as well. Thank you very much for being with us, and see you later.